Alright, hello. Welcome to the last live stream. I hope everybody is surviving before finals and taking time for yourselves, being kind to yourselves, and making sure that you just have that time away from things that may stress you out. But with that being said, today is more of a question and answer type day, so I don't necessarily have anything planned. I know that we've gone over a lot of material, so it's more of a freebie for you guys. I'm going to put everything in immediately. I'll put the form in a bunch, so you can just pop in. But yeah, just let me know if you have any questions in the chat, and I'll be here to answer them. Hello, yes, I can. Would you like to go over partial pressures of oxygen in terms of like ecosystems, ecology, or in terms of the heart, alveoli, and the circulatory system? Okay, sure, yeah, no problem. Just give me 1 second to load up some references. Okay, sorry. I just wanted to get my paper ready. All right, so for partial pressures of oxygen, I wouldn't, the first thing I'm going to talk about is oxygen within the body, and then I'm going to move on to oxygen within ecology. So, oxygen within the body, when we talk about it within the circulatory system, don't worry too much about the flow of oxygen, the partial pressures with the blood, um, with the circulatory system as well. So, really, what we're talking about with this is we're just going to talk about the Bohr effect and hemoglobin. So, the only thing that you should know about oxygen with the circulatory system is like we go to the lungs to get oxygen, we come back through the left atria down to the left ventricle, out through the aorta, and that goes to the whole body. So like that's the only thing that you really need to know with the circulatory system. With the Bohr effect, it's just talking about the blood in general throughout the body and how it exchanges oxygen to our tissues and under what conditions. So we've seen the graph that looks like this. Yikes. I'm going to redo that. And this is partial pressure of oxygen. And then this is percent saturation of hemoglobin with oxygen. We're just going to say this is increasing, this is increasing. So we just say here as partial pressure of oxygen increases, the percent saturation, so the amount of oxygen attached to hemoglobin, increases, as we can see here. But then there are things like carbon dioxide levels, breathing in, taking in a lot of air, or holding your breath, not letting your body release carbon dioxide. That's a way of increasing CO2. So increased CO2 lowers the pH, so makes it more acidic. And so lower pH means that hemoglobin releases more oxygen. And I'll put this in blue. But then what would happen to this curve is it would move this way. So as we can see here, it's actually releasing more oxygen more readily, like less partial pressure. The partial pressure that's happening over there, we can see in this curve, the decreased pH releases more oxygen to the tissues more readily. So that's why we need to release more carbon dioxide and breathe in more oxygen when this happens. And then on the flip side, we would say an increased pH means that hemoglobin holds on to more oxygen. If I drew that, it would look like this. So So it doesn't want to release oxygen. It really wants to hold on to it. So does this help with partial pressure, like the Bohr effect in our blood? Okay, cool. Do you want any further clarification on this? Do you have any other questions related to this? Okay, awesome. So I think, and I'm going back through what we talked about this quarter. Um, we talked about, because I'm just wanting to make sure that I don't want to overstep in terms of partial pressures of oxygen in the ecosystem. So we talked about respiration, circulation, um, immune system, talked about neurons, endocrine system, just the nervous system again, yep, muscle, behavioral ecology. Okay, so in terms, yeah, in partial pressure, I honestly, if, correct me if I'm wrong, I believe this is the main thing that we covered about partial pressure of oxygen. Is that correct? Okay, awesome, cool. I am doing my best right now to find a good one because unfortunately I didn't when I was studying it, so I just had to hard memorize it, but I know that there's something out there and then we can draw it out together. Okay, I'm so sorry to say this and I hate to disappoint, but I did not find anything good. Um, I'm gonna draw it out and then I'm going to come up with one that may be really bad, but it's gonna be fine. Um, so first I'm just gonna write the steps and then I'm going to do my best to draw a heart and then I'm going to draw arrows. So first, um, deoxygenated blood, I'll draw in blue, comes in through superior and inferior vena cava to the right atrium This is where the tricuspid valve is, not cupsid. That goes into the right ventricle. Which goes to the pulmonary artery. This is where the pulmonary valve is. And then in a neutral color, this is where the lungs goes to the lungs to get oxygenated, and then I'm going to change it to red. That goes to the left atrium. To the left ventricle. And this is the valve. And then the left ventricle goes to the aorta. Which then goes to the rest of the body. Ooh, sorry guys. Hearts are kind of hard to draw. Okay, so this is the right ventricle, right atria. I shouldn't be doing this in red. Do this in gray. Right ventricle, right atria, left ventricle, left atria. This is the aorta, superior vena cava, inferior vena cava, pulmonary artery. These are pulmonary vein, bicuspid valve, tricuspid valve. And this is the aortic valve. So as we said, deoxygenated blood comes in through the superior and inferior vena cava, through to the right ventricle, which then goes through the pulmonary artery, through the pulmonary valve right here. Sorry, I didn't label that. And that goes out to the lungs. And through the pulmonary veins. I should put that here. Sorry, you guys. Pulmonary veins. Through here. There's some valves in here. It comes in through the left atrium, into the left ventricle, and then goes through the aorta to the rest of the body. I think what's hard about a mnemonic about this is that it's just so long. But did going through it help a little bit? Do you have any questions and need clarification on anything? Right angle turns technical terms require very precise earning like a That's awesome. Light HMO. Oh my gosh, that is, sorry, that is like really good. I'm gonna write that down for everybody. Oh my gosh, wait. Oh my gosh, my spelling. I think it's good. It's fun. Oh, sorry. So the code is just filling in this Google form, and then I take your attendance. And then you get extra credit because your instructors have access um, to the attendance that I post for you guys. Yeah, thank you. Anybody who's popping in and out for this whole year, it's been really awesome working with you all. Thanks for showing up to everything and asking questions, always being positive. Yeah, thank you guys. Does anybody else have any more questions? I hope you have a really nice summer. Uh-oh, something happened with my screen mirroring. 1 second, sorry. Um, yes, the worksheet should be actually available on your Canvas page through your class. So they're not on Twitch or the Learning Center. They should be through your biology Canvas. Yeah, of course. Oh, yes. Let me go back to that ecology. Let me look that up really quick. Okay. So, the mark sorry, oh my gosh, hello. The mark recapture formula kind of explain, yeah, so I'm just going to write that out. Sorry, you said quick question. I'm just all over the place. Okay, so it is the number of recaptures in second hatch over total number in second hatch is equal to, yeah, sorry. In first catch over total population. So it's like abbreviated like this. And so, like, relating to the question that we had in the live stream, where it says you have a population density of chipmunks occupying a particular park, you sample several quadrants and capture 50 chipmunks, which would be first catch N1. You mark each of their backs with a small dot of red paint, release them. The next day you capture another 50. Among the 50 you find 10 that are marked. So recaptures is 10. And the amount that we captured in the second hatch was 50. So if we put this in the equation, =50 50 over n. And you do some algebra. Is equal to 250. So this is the mark and recapture method in ecology and the equation. Yeah, so just simply it's like usually it's going to be asking about the total population because this study is to see what the total population is. So generally the question will be, we captured this many and we marked them. We set them free. We got them back. We got this many back. This is how many we could recapture, and this is how many were dotted. So you're always going to get the same three variables. So just understanding how they're related is what you need to know. And to kind of help, like, the second generation will always be together. Yes. Alright, any more questions? How's everybody feeling? Oh, I'm sorry. Well, for feeling overwhelmed, everything is temporary. It's easier said than done, but definitely make sure to take at least 5 or 10 minutes for yourself. Breathing, taking a walk outside, watching something funny. But you're going to do great on everything. Summer's just a foot away. Yeah, this term is is definitely challenging. But if you think about it, you've been studying for this test the whole term, you know? Just remember to get some sleep. It's the best thing you can do. And don't overload yourself. If you're at a point of exhaustion where you're just studying and you're not retaining anything, just step away for a minute. Because it really is not going to do you any good, I promise. Yes, me too. I love taking my dog for you know what. She's sleeping next to me, so I can't say it. But um, that's been really nice, especially that the weather is clearing up outside. Of course. Yes, we can absolutely talk about that. Let me just go get some diagrams so that I can have a reference real fast. Okay, so to talk about the whole axon, I kind of like to start at the end. So I'm going to draw the whole axon, but I'm going to circle in on a part that we're going to focus on to start talking about where action potentials occur. Okay, so just to label this, this is the cell body. This is what is called a dendrite, and this is where neurons connect. So usually you'll find a dendrite at the end of this synapse here. These are called myelin sheath. And nodes of Ranvier. And then this is the axon. So I'm going to focus here and just draw this a little bit larger. So what happens with an action potential is we have action potentials that are chemical and also electrical. It's chemical because we're dealing with calcium, and it's electrical because of the polarization between the inside of the axon and the outside. So we have an action potential that reaches the end. And then voltage-gated calcium channels open and go into the membrane. And so what calcium does is it actually makes the vesicles here that are carrying neurotransmitters, such as acetylcholine, to fuse with the membrane and be released so that it can go into this dendrite, and that's the chemical signal that we're talking about. So then 3. And then on the other side of this membrane, there are going to be other channels. that are ready to accept that neurotransmitter, and then it can fire an action potential. And so what's happening inside the axon here is that it's more negative inside than it is outside. And so this is where we're seeing that sodium, potassium, voltage gated channel working, because there's more potassium inside, and generally there's more sodium outside. And so sodium actually has only the voltage gated channel is really its only way out, but potassium has leak channels which allow it to kind of freely move out little by little. They're not very large, it's not huge, but the main thing is the concentration gradient. So sodium on the outside, it's higher, and concentration gradients want to move from a high flow to low. So the sodium wants to move in. Potassium wants to move out. So leak channels, that's why I'm pushing it out. When we have, I know this is getting kind of messy, but when we have that diagram that talks about depolarization, repolarization, hyperpolarization, and then we're back to normal. Depolarization is when the Na voltage gated channels are open, so sodium is now free flowing into this axon, and then right here at the top, sodium closes and potassium opens. Okay, this is getting messy, so I'm going to actually draw this diagram on the next page. So here, Na gates open. Here, Na gates close. Potassium open. Potassium remains open. And this is why we have that lag here. This is the hyperpolarization. Because potassium is continuing to flow, and then eventually stay close. So this sudden change is what we call an action potential. And this action potential is what moves down an axon. And so if we're moving back here, it would go in through the dendrites all the way down and then release neurotransmitters to fire another action potential. And action potentials can either be excitatory or inhibitory. Does this help? Okay, awesome. And let me get the so resting is -70. Threshold is -55. Generally, it reaches +40. And hyperpolarization is usually around 90. Just to add some numbers. But yeah, so we have just a couple minutes left. Any last minute questions? Anybody? Yeah, thank you everybody. Thank you so much for this year. It's been really awesome teaching y'all. I hope the rest of your journey here is righteous. I actually don't know the answer to that question. It's a little bit beyond the scope. The only thing I know about is like how there are multiple excitatory and inhibitory neurons that are firing at all times, and so the outcome is whether or not one or the other overpowers whether one overpowers the other or not is what I should say. So I actually don't know. I'm sorry. I keep putting the form in the chat just in case. Okay, y'all. Well, enjoy your summer. I hope you all have a really nice and well-rested time. I will see you around, and of course, as always, email me if you have any questions, and have a great rest of your day. Bye. Thank you guys so much.